Hello, I'm Glenn Darling from the Open Horizon team, and I'm here today to tell you about the model management system, which will support your machine learning or ML models or any large data files. So the MMS enables independent life cycles for your code and your large data files. So your code can run continuously through a data file update. And in other words, you can update your ML model and have no interruption at all in the inferencing services that you're providing with that model on your edge devices. There are two components in the model management system, the Cloud Sync Service or CSS and the Edge Sync Service or ESS. And typical usage is to use the Open Horizon HCN command, the CLI, to publish a data file to the CSS. And then on your edge nodes, your local software there running in your containers will use the local ESS REST API to access your new file. And how it works. The CSS will deliver the new file to the ESS on the appropriate set of edge devices. And the way it selects those edge devices is normally based upon a deployment pattern or a policy. And these are the two mechanisms that you would use normally in Open Horizon to deploy your Docker containers out to the edge. But you can also use them for deploying your large data files. And in addition, for the MMS, you can specify a manual list of specific edge nodes where you want the file to be delivered. So the ESS makes the file available locally on its REST API on each edge node. Optionally, you can use a little utility that I wrote called the MMS helper, and there's another video in the LFEdge YouTube channel about the MMS helper you can watch for details. But the MMS helper can automatically deliver your new files to your container's file system. So you just keep checking your local file system and you don't need to interact with any REST APIs. So for details, you can see that link right there. Now let's take a closer look at how the MMS works. So typically you'll have a software engineer who creates machine learning applications, inferencing applications, and a data scientist who is supplying ML models to be used by that application, and they collaborate to create a Docker container that contains both of them. And of course, maybe that's the same person who's doing both those roles, or maybe you have a whole department of folks on the left and on the right there. But ultimately, you'll create a Docker container and then publish it to the Open Horizon Management Hub, and in other words, you'll publish it to the exchange. And again, you'll use the HCN CLI there most likely, and then you'll have to register some edge nodes as well. And once those nodes are registered, the Open Horizon agent that is running on each of those nodes will be communicating with the switchboard, polling it to see if it has any messages from the agbots. And the agbots will jump into action and do their usual thing. And I'm not going to go into detail about that here. But the end result will be that node agent on the appropriate set of nodes will download and validate your container and eventually get it running on those edge nodes. Now that's all good, but eventually your data scientist is probably going to come up with a new version of your model, and we find that the model files tend to change more frequently than the actual code that makes use of them on the edge machine, especially if you've got a loop where you take the data and train in the cloud and you want to continuously update your ML model and your edge devices. So when that new model comes along, you could go through the same process again, where the ML model, the new version, is built into a Docker container containing the old version of the app. You publish that and go through the process that I described. And that would mean that the node agent on each of those edge nodes will need to shut down your old container and download your new container, validate its cryptographic signature, and so on and so forth, and eventually start running your new container that contains your old application and your new model. But that means there's some service interruption during the time after the application is shut down before the new application can be started up with your new model. So we wanted to do something a little bit better than that. So that's why we came up with the MMS. And with the MMS, you, instead of publishing a new container, you just publish a new version of the model. So the data scientist can directly publish using another HCN CLI command to the local management hub, and the CSS will receive that, and then the node agents on the appropriate set of nodes that are identified by your policy or pattern or your explicit list of nodes, they will reach out and communicate with the CSS, and the net result will be that the ESS will make that file that you published available on each of the appropriate local nodes. And then your application can be polling the REST API locally there on the edge node. It doesn't leave the node, just asking locally of the local ESS. And when a new model is available, it can consume the new model, and then at some point it does an inferencing with the old model, and then the new model has arrived. It just can cut over and start using the new model for the next inferencing, and so there'll be no interruption whatsoever in your service. So let's review. The MMS enables independent life cycles for your code and your large data files, and that's important if you want to maintain uninterrupted service on the edge. You can update your ML models with zero interruption in your services. Typical usage is to use the HCN command line interface to publish a data file to the CSS, and then on the edge nodes, your application software will be polling the local ESS REST API to access the file. Optionally, you can use the MMS helper, and it will deliver files directly into your container file system, so you don't need to use the REST API, which will be simpler for some users. And there's a link again to the MMS helper. I hope you found this useful. If you wish to have some more information, you can contact me in any of the ways shown below. I'm Glenn Darling at us.ibm.com. I'm Mosquito on the LF Edge Slack channel, and I'm Mosquito at darlingevil.com.